So now we're going to talk about binomial distributions. So there's three characteristics of a binomial experiment. You've got a fixed number of trials, which means you're going to do something a certain amount of times and you're not going to go past that. And within these trials, you have two outcomes. You have success or failure. And you can denote which is success and which is failure. So we denote success, the probability of success as a P, and Q as the probability of failure. So if you add the P and the Q together, you get 1. So remember, probabilities have to add up to 1. So right now we're looking for basically a yes, no, or like a head, tail, and those probabilities are going to equal to 1. So for the N trials, they're independent and they are repeated using identical conditions. Because these trials are independent, the outcome of the first trial is not dependent on any of the other trials. So think about it. If I toss a coin 10 times, my first flip has nothing to do with my second flip or my third, fourth, fifth, all the way up to 10. That's what that means, that none of the trials are dependent on each other. So another way of saying this is that for each individual trial, the probability P of success and the probability of Q of failure remains the same. And we write this as the distribution approximates the binomial, comma, N, comma, P. So there's some ways that we can talk about binomial probability scenarios. We can look for the exact number of successes. We can look at the at most number of successes. We can look at fewer than, we can look at least, and we can look at more than. So this looks kind of crazy right now, and you're like, where are you getting this from? I promise it'll make sense as we keep going. So let's do a problem. Let's just talk about binomial, and then we'll go back to that. Approximately 70% of statistics students do their homework in time for it to be collected and graded. Each student does homework independently. In a statistics class of 10 students, what is the probability of at least 4 will do their homework on time? Students are selected randomly. All right, this is a binomial problem because there is only a success or a blank, comma, there's a fixed number of trials, comma, and the probability of each success is 0.70. Okay, remember we talked about there's a success or failure. So the missing word in there is failure. If we're interested in the number of students who do their homework on time, how do we define X? And what values does X take on? D, what is failure in words? And the words at least translates to what kind of inequality for the probability question. All right, so let's talk about this. So the capital X equals the number of statistics students who did their homework on time. Okay, that's what we're doing. Remember, we're defining what that is. And the small x is 0, 1, 2, up to 10. Remember, no students could do their homework. So when you do these distributions, always remember to put 0 because 0 can occur. All right. Failure is defined as a student who doesn't complete their homework. So remember, if the probability of success is 0.70, I'm going to make this bigger so you can see what I'm going to do. Then the probability of a failure is Q equals 0.30. Okay, where did I get that? I got that because remember, 1 minus 0.70 equals 0.3. And then again, the number of trials is 10. So when we write greater than or equal to, which is at least, we do P where X is greater than or equal to 4.